Hi, good day, everyone. So today we'll be talking about event-driven microservices, when to use, how to use it. So today we'll be having a very deep dive about the evolution of how event-driven microservices actually came about and the reason for it and why it's majorly been pushed out there by industry, big industry, tech systems, and the reason why they're actually using it. Some of our agendas today, it's all about how the microservice actually evolved to an event-driven aspect, the core concept of it, of the architecture itself, the benefits, the challenges, when to use, the design pattern, the best practices, and the tools and technology for it. Then we also have a keynote whereby I would actually like giving more in-depth of reason why you should actually want to use it and what are the cases and scenario whereby it's important for you to actually like move back if it's not a very case scenario whereby you should actually use it. So let's start about event-driven microservices itself. So if you think about how the internet actually evolved with the number of users we have today, then you think about okay, around 2000 we had about just 6% of the entire world population, which accounts for about 3.3 million and 361 million users actually using the internet. And when you look back in 2010, it's about 27% of the entire global population actually using the internet. And as far back as 2015, we had about 40% of the entire global population using the internet, which accounts for about 3.5 billion users. So these users are actually increasing yearly, and there is need for us to actually have system that could actually like carry out various information and various users with these users. So if you look at the design pattern from the beginning, we started with MVC, that's model view controller kind of systems, whereby the users have the model, the view, and the controller. This segregation actually helped us to modularize our architecture, whereby we can actually see pinpoint where the failures is coming from, the entry point, the failures, and all that. Then we move into the microservices. Then the microservices had its own pitfall, which is most of these microservices intercommunication is due to HTTP request. So the user sending a request to these certain services, and the certain services have to like communicate with another service through HTTP request. And if you look at HTTP request, it's actually a very blocked kind of communication whereby it's more synchronous and you have to like wait for the response, but actually like get the response immediately. So then we now move into event-driven architecture microservices, which actually uses event instead of this HTTP request. So why is this service important to us? So first is that like this service is actually emit this event, then they could actually be read by various services. So it's important to understand the concept of the fact that these events are messages or communication that various services could actually read through. And why is it important to us, or why is it important to the business of today? It's actually important because we need to actually improve the scalability of our services, of our system, make it more fault tolerant, and also the reliability of the system. So that's one of the key importance of us using event-driven microservices to actually improve our reliability of our system, to actually houses these 3 point something billion users that are actually using the internet of today and are doing various transactions, various processing, various communication over the internet. So today we would be diving in depth into the core concept of it. So what's the core concept that actual microservices that event driven have? First is the event itself. So the event is actually like a statement of fact describing something as occurred. For instance, if you imagine an e-commerce system, first you come into the e-commerce system, you glance into the product, you see various services they offer, and probably you click, okay, I want this, I place the order. Then this order is communicated as an event that, okay, a user actually wants to place an order. So then this event actually like probably send a notification to the message, like notification to like send an email, like, oh, this user is actually requesting for this order. So in essence, an event is a fact describing a state of what's going to occur. So, and how are these events actually generated? The events are generated from the producer. The producer is the service that actually create this event for these consumers to actually get. So you can look at a producer as like the house of that event itself. So for instance, you're in a service whereby let's give a fintech service for example. So a user actually creates a transaction, then you have like a message that, okay, transaction being placed. So this message of transaction being placed will communicate to the ledger that houses the housing of transaction, which this information is present that, okay, first, this transaction has been created. Then the transaction has been created event actually speaks to both either the audit, which actually check, okay, is this actually true? If it's going to go through the fraud communication, the fraud will actually still check if this actual particular transaction is actually going on. Then this information goes into services of different type, which makes it easier not to have a block or a more of a synchronous type of transaction. Because when it's synchronous, then when there is an error in any part of the services, then we have a complete failure without any retrial or without any form of handling of these errors. And this kind of scenario makes our system not reliant and it's not resilient enough to actually house the number of users, internet users of today. So let's talk about the actual mechanism used for this messaging, this event-driven. They actually call brokers. So these brokers are the middleware that handle this messaging, the routing, the storing, and the delivery of this message event. So an example, a very, very prominent example is the Apache Kafka, which is very known in the industry. And we also have the AWS XNN, which is also very known in the industry. We have the RabbitMQ also, which is known. And we have the one from Google, which is the Pub and Sub, which is also very, very known for handling this event communication within our services. So let's go further for the benefits of actual event-driven system. So one of the benefits is actually loosely coupled. So being services being loosely coupled means like you can actually have different service points and they are not affecting each other. So they are independent of each other. And this makes it very, very high availability in the sense that first is that these services are independent of each other. That means you can actually scale these services. You can actually scale it. You can add more instances of these services. They are not affecting each other in any way, which is very, very good. Then we have the aspect of it being more for tolerance, because if a particular service is down, then you can actually have a scenario whereby the entire platform is not broken down by that single services. An example is whereby you have an e-commerce system and probably the order services down. Then customer can still check out if they have those items on their carts. So it's not affecting the checkout aspect of the service, but only the order services down. So this kind of architecture actually makes it easier for businesses to scale, to couple this, to scale their business without having this scenario whereby they have a lot of customer support asking for, oh, well, your site is not going through, your application is not going through. Then you have a more seamless kind of way whereby, okay, the order is actually down. Then you fight through with the order, you try to check what's going on the other aspect, and this gives a more seamless kind of approach. That's where the loose coupling of these microservices, event-driven microservices, actually help us a lot. Then the scalability. So each component can be scaled independently. I think I mentioned that. Yeah, so you can actually scale these component or services independently, because first is this, you have these services and you can actually scale them horizontally. That is, you add more instance and the load balancer is actually checking for load on this instance, compared to the usual methodology of whereby we have just a single instance, and this single instance, actually, you need to like scale vertically, whereby you start adding more CPUs to this instance, start adding more CPUs to actually make the actual processes work, which is in essence, you're spending more resources because some actual components don't really need so much of these resources. An example is if you want to think about Twitter, for example. Yeah, so Twitter has more like uh write service than actual read. So like a case scenario. So if the Twitter has a service, as like a service of okay, the write, that means people that are posting the actual tweets as a service, and have another services which actually like people that are actually reading the tweet itself. So if you look at it, if you actually adding more, if it's a monolithic architecture, you have to scale both of them together. But when it comes to event-driven microservices, then you have to like look at it in a way whereby, okay, which of the services are having more users? Which of the services are having more users of or more usage on? So, and you will look at it in a way by the read is actually having more users because a lot of people are actually scrolling through their Twitter feeds and learning new to content through the Twitter feed. So, if you want to scale this kind of services, you have more skill on the read aspect because this is being used more. So, you have more computing there compared to having more computing on the write, which is writing of a post might not be as populating like compared to reading of the post itself. So it's important to actually understand the scalability and how it actually benefits microservices which are event driven. So another core benefit is that it's asynchronous processing. So when we talk about asynchronous processing, that means we're talking about services that actually could actually work without depending on the dependency to actually get a return. So if you look in depthly, for instance, you are trying to make a payment. You're trying to make a payment, and you type about £500 or 500 US dollars, and you want to send it to your friend. And you type in and you post this sending of fund. Then just imagine it's a synchronous service whereby that means you have to send the phone, it has to validate, and still go directly to that user. This is actually impossible because there are a lot of dependencies involved. Because, for instance, you have this scheme dependency, like the scheme of payment itself. There is no way you would actually communicate with the scheme and get instant validation that this money has been sent, because this communication is not like so fast, because they have to like do some edge cases whereby they do fraud check on the actual payment itself. So having a synchronous services can actually be a case of a banking solution whereby it depends on the scheme itself. But this synchronous process means, okay, oh, I'm doing this transaction, but I don't have to wait for the return of it. But then this information will come afterwards. So an example is this. So when I post a transaction of about £500 or 500 US dollars, then it goes to like the anti-fraud, and all these processes are being checked. Then it goes to the scheme. I'm not waiting for the scheme to actually give me a return, but the end process is that at the initial stage, I'm getting a processing. But when the scheme they find out, okay, wow, okay, this transaction should be successful, that I've credited the beneficiary, then I get an event of okay, transaction being delivered. So these are very, very helpful case of asynchronous processing, which we actually get from event-driven. Yeah, so we get these kind of ways from event-driven architecture, which we have today. And another very, very core benefit is the fault tolerance. I think I've made mention of this couple of times. I think fault tolerance is one of the most prominent benefits of this architecture, because when one system is down, the entire system is not down. It's just that particular services that is down. So you can have a system whereby, oh, fine and good, the order system is down, but the checkout still works. So when you have your orders in the cart, you can still check out without having to wait on the, oh, the service is down and the entire architecture is down. And a very, very good thing about this event is that you can actually store them in the broker. So you can store this event, and whenever the service is up or available, the services can actually get these messages and actually process it again. So it's a very, very good benefit of event-driven system. So let's further on to the challenges that we can actually face using this system. So actually, there are a couple of challenges, and some of these challenges are actually being mitigated with various methodology in system design. So a very, very prominent one is the ordering and duplication. So just imagine a scenario whereby the user press checkout or process payment multiple times. Then there's like an event of multiple checkouts. And this could be due to probably internet error, like a scenario whereby like there's a cut in communication, like a timeout or whatever it is. But then you have duplicate events that has been communicated to probably like the email notification service. Then you get like multiple emails. So this kind of scenarios, it's actually common in event-driven architecture. But then you can actually solve this with things like idempotency keys. You can actually have like correlation IDs and all that could actually solve this issue of duplication of request. So yeah, it's actually an issue, but still there are mitigation regarding it. So then we have this aspect of consistency. So if you look at it in the payment system, we have a scenario whereby it's very, very important for the ledger to actually be consistent. So now you are having a scenario whereby you have multiple ledger database and you're sending events to these various ledger database. Then you have a scenario whereby those consistency might not be it due to the fact that this system actually needs to read those events. So these events are actually coming from the producer, like I said in the initial stage. So if these events are actually coming from the producer, then the consumer has to read this. So if the consumer is not actually reading it, probably due to failure or like system down or something, then there is a bit of lagging inconsistency, which is actually like very, very common in this system. And the way to actually mitigate it is to have like a dead letter queue, which you can actually reprocess those events so that the entire system is more consistent with the current true nature of that particular event. And also you could have like in Apache Kafka, it has something called whereby you can actually like create a topic for those dead letter queues. So those topic can actually be like, okay, so if there's a failure or if this particular event is not being able to be processed, then send it to this queue. So this queue would actually process those events that have not been processed by a particular microservice or a particular service itself. So there are a lot of mitigation towards these challenges that we have in event-driven system, which is quite nice. So like another one is about debugging and tracing. So it's quite complex to have to debug services because there are actually a lot of services around. Like if you have a very big enterprise whereby you have like transaction services, you have the ledger services, you have like the accounting services, you have multiple services. So whenever there is an issue, it's actually very hard to actually pinpoint, okay, except if you have like things like service metrics that actually share this information with you real time. It's actually hard for you to actually pinpoint, okay, where the service has been having issues. So, and it's important to actually know that it's more of a team kind of thing. It requires a speciality of actually debugging these microservices, and it's actually very very hard for you to follow the flow of the request itself and how these requests actually get come in place. So I think one of the ways to actually mitigate this is to actually have like a correlating ID. So this correlating ID would actually help you trace throughout the metrics of how this transaction or this particular event has been going through. So you have this correlation ID to actually check the logs to see, okay, this is where the service is having a breakdown. This is where the service is having an issue or so. And you can actually have a scenario whereby you have like a context ID. So this context ID, use it to like debug, check for what's going on. Yeah, so I think you could actually mitigate that through using either context ID, correlation ID to actually trace an event if it's having an issue. So another one is schema evolution. So yeah, day to day we have different type of schema, which is like how the representation of data is actually being sent. So schema version is actually very, very important in microservices because a typical example you can think of is like, okay, today you have an application that takes in first name. No, you have an application that actually takes in like full name and amount, then probably further information like emails, and probably due to government initiative to actually make, okay, KYC more usable in the sense that they need to have like first name and last name, and you have already developed an application that have full name. So you changing the schema to have like first name and last name would actually break other microservices that are actually looking for full name. So how it's important for us to have like version of this schema so that whenever we are communicating to a microservice, we actually say, okay, this schema version is version one. It has full name. That was the previous version. Then the version two has first name and last name. So there's no confusion whenever a service or a consumer is actually reading this request. It says that, okay, yeah, there's first name and there's a last name in the version two instead of the previous version that only has just full name. So it's important to actually understand that this schema revolution has to be recorded and have a registry of entry so that you don't have a situation whereby a consumer is expecting a particular data and it's not getting it. Yeah, so then we have the operational overhead. Yeah, this is one of the critical one that affects microservices because first is the knowledge of itself. Then it requires managing these broker events. It requires you having Kafka. It requires you having those architecture that actually have to do all these things, scaling the topic, data retention and all that. And it requires a lot of skills too to actually debug this issue whenever there is in microservices. So I think that part of it itself, it's one of the challenges that's it's been mitigated whenever you have cross-functional teams that could actually handle this and actually have the knowledge about it. So I think the knowledge about it is very, very important across team that are working on event-driven microservices. So let's take a look at when to use and also avoid when. So when to use, I think when you need real-time reaction to business events, it's very, very important to use microservices. So when you have like an example is real time, it's like even a sport betting platform would actually want to use a microservices to actually interchange this event of probably the increase in score and probably things that actually have to do with events that are relating to the core concept of what the business purpose is. So it's very, very important that when you are having an architecture or when you're having a services that depends on real-time events, real-time payment infrastructure like FPS actually uses asynchronous services, because obviously these services need real-time information about what the current context is. So then the business have to actually view microservice as, or event-driven microservice as, a very, very critical option. So yeah, I think secondly, loosely coupled and independent scaling. So when the users are actually growing, when you start having like billions of users, billions of transactions, like millions of things that are going on in your platform, then you see that you start having drop down in service requests. You start having latencies that are increasing day by day due to the fact that these services are actually not scaling, or you're scaling it with CPUs, adding more RAMs, trying to actually scale it more vertically. Then you actually start seeing you're increasing cost in the over general thing that you're actually doing. So it's a way for you to mitigate this. It's actually to decouple these systems. So when you need to decouple your system, then it's very, very important for you to actually think towards event-driven microservices. And also when you are having like high volume of stream data. So this is also very important, like a scenario whereby you're having like to actually load content, like for instance, like YouTube, like you actually having to load those video. Imagine having to load a terabyte of video. It's not actually very, very good user experience, because this data would be there without having the need. So for instance, when you open a playing application and you actually play the first few seconds of it, and you're not interested, you're actually just having a stream of bytes that you've actually visited, not the entire stream of content. So it's very, very important for you to have this mindset of thinking towards microservices while you're having a very high stream of data. So the last part is system must react asynchronously. So when the system has to react asynchronously, you have to think about, okay, when this come in, this would actually make this event happen. So when a user actually register, you need to send me notification. So these kind of flows that you don't need a block kind of process, which are non-blocking, is actually very, very preferable for you to actually start thinking about using event-driven system. So when to avoid using event-driven system? So first is that workflow are simple and synchronous, like CRUD operation. So like if you have like a app that does not actually, probably like a to-do list, you just have to actually add, remove, and probably delete, scroll. Like it's a very, very simple process. You don't need that ambiguity of or complexity of microservices event driven. That's event driven. So you don't need those kind of complication in simple workflows that you could actually do without having multiple services that are actually handling just one single request or single event. So you don't need to overdo it when you're having simple workflows. Another thing is your team could actually lack these technical skills of observability, events management, and all that. So that's why it's very, very important when you're thinking towards event-driven system, you need to actually have the skill, like this team that have the skill mindset of how to debug this system, fix these errors and all that. So I think that's the very, very important one when it comes to like event driven. You need skills to actually manage this event, and for you to not like have failures, you need to have enough skills of users. And if the workflow is not too complex or doesn't need too much synchronous process, then there's no need for you to actually think towards event driven. But mostly when you're a business going from 500 to a million user, then you start thinking, But these things can actually be done gradually. It's a gradual process most times. So there are a lot of migration that I had to do in the past that I actually have to do from a monolithic to a microservice event driven. Then it's actually a gradual process. You start from each service, you start either from transaction, you start either from onboarding, then you start building up this process towards the end of it. So let's go. Yeah, so what are the common design pattern? I think the simplest one is event notification. So the event notification is you just emitting signals or events about something that happened. An example is usually just registered on your application. You send an event that a user has been created. Then the user ID gets sent to email notification, and the user gets an email notification about them registering. That's just like the simplest part of notification, like event-driven one, which most people are actually conversant with. Then we have the state transfer. This quite a bit, not too complex, but it has to do with you having that data of the event. So for instance, you're sending a transaction event, then and you're sending it to the ledger. It will probably contain the transaction ID, the amount, the beneficiary, the debtor, and all that. So you have those information within the context of that event. Then you can say it's a state transfer kind of event design pattern. So it actually promotes you actually decoupling these services because you have a data that has been shared across all, not just the context, which is just probably just the ID. So it's very, very good for you to have this state transfer kind of pattern when you are dealing with more data that actually has to be synced alongside the entire application. Then we have event sourcing. So this is a system of you sourcing for truth. So this actually works more in banking system whereby they have a lot of data they have to actually go through. So probably like a user, you want to get the amounts, you want to reconcile the balances. So the user, if you look at the amount of the current balance of the user, it's more like a reconciliation of all the transactions done in that month. So if you want to do this, you actually have to do an event sourcing of all the processes of either credit amount or debit amount. So this event sourcing is actually a broader one because it has to do with you sourcing for those events. A popular tool use it's usually like data lake tools. They use those big, massive, big data to actually source for these events. Yeah, so let's go to the best practices whenever doing you actually regarding to use event-driven microservices. So first is that the use of schema registry. Like we said, we have issues around the challenges of schema. So when the user changes from, when the user or the business requirement changes from full name to first name and last name, then you think about, oh, you need to have this schema registry whereby this structure is actually there and there's versioning based on the need of that service. So for instance, you're sending probably version 1 and version 2 out as an event. Then the particular services that's still structured to use version 1 would actually use it without no problem and ignore the version 2. So it's important for us to have this registry that houses this schema type. Then we have ensuring idempotency. So what this idempotency means is for you to have this uniqueness across all the events. So you are not having a replicated event being duplicated as messages. So when you're sending a particular event, you know that, okay, when this particular event of the same idempotency key comes in, then you don't need to reprocess that event because that event has already been processed. And this is very, very important, especially in transaction case, whereby if a user is sending a transaction and it contains a particular idempotency, then you can't like process the same transaction that has similar idempotency because that means you're reprocessing the transaction. So that means you're sending multiple transaction that the user actually intend just single. So it's very important for us to actually think about how this services are actually idempotent. Like they have this uniqueness of that processing of particular events. So we have multiple scenarios of events being duplicated or messages being duplicated. Then we have the date later queue. I think I've mentioned this before. So it's just a way to fall back to those events. So those events that have failed or those messages that have failed, then we need to reprocess them. We could actually do this either manually or to automated process. Then we have the tracing and observability, which has to do with you tracing those logs using correlation ID, using end-to-end ID, using FPS ID. So those ways to actually trace this event is actually very, very important, especially when it comes to either payment, transaction. You have to actually have those ID conventional to trace those log metrics for you to trace, okay, if this transaction failed, where was the point of failure, where was the point of entry. So yeah, you can use various tooling that could actually help you do this observability. One is open telemetry, we have grafana logs and all that. We have cloud front and CloudWatch from Amazon, which is actually very, very notable for tracing out these logs and event. But inside the system itself, you have to actually put in those information like, okay, the end-to-end ID, the idempotency key, the context key, to actually have this trace itself. So then we come to naming convention, which is actually a very, very big fight between developers. Okay, yeah, I want to name this. Yeah, you have to like have a standard of naming, which is actually consistent across. So a very prominent way is to actually have the entity that's like, okay, order being placed. So the order is the entity. So the order is the service itself. So the action is being placed. Like the place means like, okay, you're placing this order. It's an action. So it's a very, very good convention to actually name this consistency across your application. So you have this way of understanding what the event is actually is. So let's move on. The tooling and technology. So yeah, I think I've made mention of event brokers, which the first one is Apache Kafka, RabbitMQ, AWS, SNN, and SQS, and event or pops up by Google itself. So these are various event brokers. So what these event brokers do is to actually like pick up this event, communicate it, and also store it. They have storage, like a very, very temporary storage. They have various mechanism like streaming itself, like you can stream this event. So these are various technologies that actually have to handle the event itself. So it's very, very important for you to actually onboard your developers to actually understand how this works. Then we have the schema. So the schema has to do with like what kind of scheme or what kind of representation of data you're actually outputting. So we have the JSON, the Avro, the protofab of. So depending on the kind of data you're actually communicating within your system, would actually define the kind of data scheme you're using. So you can use JSON, which is very, very popular across APIs, or you can use Avro Binder when it comes to very, very big data transfer, protocol buff, if it's a binary data. So based on those information, would actually decide what kind of event or schema type you want to use for your event. Then we have the observability, which is still alongside you tracing or having the metrics of your system. So you can use Grafana, you can use Prometheus, you can use OpenTelemetry. They have various more these observability tools that helps you debug the system, that helps you check for errors, that help you check for prone kind of things that you need to know about your system. Then we talk about infrastructure. So most of the infrastructure like Kubernetes, which houses the node of this architecture itself, Docker container, which also help you wrap this versioning of your actual container type, the IAM for deployment, the Terraform for state management of the actual application state. So these are architectural tools you need to get conversant with if you're planning on moving towards an event-driven system for your business. So it's very, very important for you to think alongside the tools while proposing this architecture to your business goals or your business itself. So think about the tooling, and yeah, make decision from there. So what are the key takeaways? So first is that I think the first key takeaway is to actually think about the event-driven system as enabling decoupling and a reactive system. So if your business goal is to actually have a scenario whereby you can have these decoupled services that are really, really fault tolerant, that you don't have to have this interdependency on failures of each other system. So then you start thinking about a reactive system whereby the state will actually change the state across your services. So then you start thinking of event-driven system. So it's very, very important for you to actually understand that, okay, event-driven system are meant to actually have a decoupled reactive state kind of system. So there is no dependency on a particular system like in a whole. So it's services in general communicating together as one without like strict dependency on failures of the other one. Yeah, so it's a very, very good way to actually look at it. And also it's ideally for real time and scalable to system. So if you're thinking about a real time kind of system, either in fintech, either in e-commerce, either in every services that you're thinking of, either in sports, then you think about having real-time data presented to your user, then you start thinking towards event-driven system. And when you're thinking about scaling your system horizontally, instead of adding more CPUs, trying to add more data centers, trying to like increase the intensity of your hardware, and you're trying to think of more of chunk of this system, like nodes of these systems, like you having more instance of this system, then you start thinking towards a scalable system of horizontal scaling. Then you need to start thinking of event-driven systems. So they are ideally for that. They're actually meant for that, and they're actually meant for the population of the internet users of these days, which accounts for about 67% of the global population. So we are increasing in numbers of people actually trying to use the internet, and you're increasing in number of count on your business. You're increasing in number of count of what you want to do. Then you have to be able to scale your system horizontally, because you need to just like spin up another instance when the other instances are being overloaded. And you can do this with like adding like a load balancer to actually detect, okay, when the traffic is about like 70%, then spin up another system. And a very, very good idea is, especially when this Black Friday thing comes in, then we have multiple spike, a lot of spike on systems. Then it's important for you to understand these metrics and to actually like understand how your system would actually scale in general. So in a nutshell, when you're having a system that you have to scale often or due to lag spikes, then you can actually start thinking of event-driven ways of actually making these services decoupled, real-time, and scalable. So another thing is that it actually requires strong observability and schema discipline. I think we've made mention of this observability. It's actually really, really important for you to know how the pattern of the events are going around your system. So you either having a context ID, you either having this end-to-end ID to actually like define where the event actually starts from, the processes that actually have gone through, how you can review the logs, understand what's the impact on your system, and having this schema discipline, which I refer to as like changing business purpose whenever the schema of data is actually changing. And I think I give an example of first name, full name being changed to first name and last name. So if you don't have this schema discipline of you having these versions of various versions of schemas that actually the other consumers will be requiring, then it's a very, very big problem. Yeah, so there will be a very, very big gap between the entire architecture itself. So I think it's a very, very good thing to actually think about if you're going for an event-driven system. So yeah, and also like I made mention, yes, start small. So start chunk by chunk. So you don't have to like go through the entire thing. Like for instance, you need to like migrate one service after another. So for instance, you can start from the onboarding service. Yeah, get a hold of it. Send email notification to the notification service. Send, yeah, so just start small. Don't like migrate your entire application, yeah, overnight. Then you have a very, very big issue of this understanding the context and flow of the system. And also do it when there is need for it. And the need for it is when you have a real-time system that you need to scale, system that the workflow should be asynchronous, not just simple workflows. Then you're changing to an event-driven system. Then that's a very, very overkill. Yeah, so you need to actually think about when there's need for it. And if you're actually going towards that way, then you need to actually think about migrating chunk by chunk, not just the entire system at once. So you start services by service. Then if you do so, you would get a resilient system, a system whereby if there's a failure in one system, you don't have any problem to actually worry about the entire system being broken down. Then you fix the failed system. And the good thing about these brokers is they're able to actually store this event for a while before, so you can actually roll back this event. So you can actually like play this event and replay it again. And the good thing again about this resilience is if you have an idempotency key, then you're very, very sure that duplicated events are not being processed multiple times. So it's the result is actually very, very beneficial, especially for big system or big organization that have multiple users, like millions of users. So, and you can actually adapt this for your system while growing. So an example is this, a case scenario whereby you have about 1 million users. Yeah, you can start thinking about, oh, I'm getting more users and I need to really, really start adopting to this futuristic growth. Then you're thinking about the number of percentage of users you're getting daily or the number of transactions you're doing. And then you just need to have these metrics to actually be able to actually think about futuristic growth. And when you're thinking about that, you need to start thinking about your architecture. You need to start thinking, okay, currently I'm using an MVC kind of architecture, which is monolithic. How am I going to like move towards microservices, which could actually have different services on its own? Then when you're thinking about microservices, then you can actually start small from using a block system, which is like an HTTP request across services. So like instead of you using events directly, you use like HTTP request across services. Then you need to start thinking futuristic about using events, because this event actually, with what we've highlighted so far, it actually makes it easier for your system to be more reactive, and which is the real goal of a business when we have multiple billions of users and thinking about growth stage of 50% more increase in users. And when you're making your marketing goals, you need to start thinking about how you can actually increase the scalability of your system, because obviously all businesses want to grow and the growth comes from having a scalable system. Because when your users are coming in and they are not able to actually do some things, then you have a deadlock here, then you have issues with your system. So in essence, we need to start thinking towards this goal of having a more resilient, a more decoupled, and a more reactive kind of system. So on a final note, yeah, I will be taking in questions now. Thank you.
All right. All right, good one. So yeah, this finalizes it. Let me stop the recording.